As this report period ended on September 30th, the first Saturn space vehicle, SA-1, had been erected on its launching pad at Cape Canaveral, Florida, and was undergoing final preparation for its history-making launch. The 3 eventful months of work and planning leading up to that climactic moment will be covered in this film report. Final checkout of the SA-1 booster, together with its dummy second stage and payload, had been underway in the Quality Division at Marshall Space Flight Center since June 12th. Among the items checked was the vehicle's stabilized platform, known as ST-90, which was mechanically tilted on this platform to simulate vehicle attitude changes. In this manner, attitude errors could be introduced, and correction by the control system observed. Also verified was the telemeter ground station, the instrumentation system used to monitor information on the operation of all systems during flight. The station is equipped to receive 900 channels of information. Culminating the various systems tests was the simulated flight test, in which all functions were performed in launch and flight sequence. With the successful accomplishment of this test, the SA-1 booster was accepted as flight ready and released for shipment to the launch site. On August 1st, the SA-1 booster, dummy S4 stage, and dummy payload were touched up for shipping. The S5 dummy stage had already been shipped last April on the trial run of the Saturn barge Palaemon. On August 5th, the SA-1 booster and payload were transported to the Saturn barge dock on the Tennessee River. The S4 had been moved the previous day. Here the units were loaded aboard the Palaemon to begin the first leg of their 2,200-mile trip to the Cape. Several hours later, the Palaemon's cargo was unloaded just above the damaged Wheeler Dam, where collapse of a lock last June had temporarily interrupted river traffic. The units were then hauled about 1 mile overland around the dam on a road which had been specially built by the Tennessee Valley Authority, and loaded onto a second barge, the modified surplus Navy vessel named Compromise. The day prior to movement of the flight booster and inert payload, the water-ballasted Saturn booster simulator plus the Flight S4 dummy stage had been taken over the Huntsville-Wheeler leg of the trip to verify loading and unloading procedures. The entire transfer operation of all units from Marshall around the dam to the Compromise went smoothly. The Compromise's circuitous voyage took it through waters of the Tennessee, Ohio, and Mississippi rivers, the Gulf of Mexico, and the Atlantic seaboard. On August 15th, after a 10-day journey averaging about 9 miles an hour, the Saturn carrying craft arrived safely at its destination, Cape Canaveral. The dummy payload was the first unit to be unloaded from the Compromise. Then the huge Saturn booster was taken off and towed directly to the launching pad about 2 miles away. The dummy S4 stage followed. Both the S4 and the payload were hauled to Launch Operations Directorate's Hangar D for temporary storage. After checkout and adjustment of the launching pedestal support and hold-down arms, LOD personnel prepared for the painstaking task of erecting the gigantic booster, following the steps outlined in the erection procedure manual. The Saturn booster, some 80 feet in length and 21.5 feet in diameter, was raised for positioning in the 310-foot-tall movable service structure. Then the booster was slowly lowered onto the pedestal from which it would be fired. And the horizontally retracting work platforms of the service structure were adjusted to embrace the vehicle. Installation of the long cable mast was next accomplished. The mast provides electrical, pneumatic, and cooling connections for booster checkout, monitoring, countdown, and rapid disconnect for the booster prior to liftoff. The long cable mast will be used for SA-1 through SA-4 in lieu of the umbilical tower. After the booster was in place, the inert S4, or second stage, measuring 40 feet long and 18 feet in diameter, was raised into position and mated to the first stage. Then the inert S5, or third stage, 20 feet long and 10 feet in diameter, was hoisted aloft and mated to the second stage. Finally, the inert payload for the first Saturn flight, a Jupiter nose cone and aft section, was lifted and mated to the third stage. And the fully assembled Saturn, 162 feet high, stood enclosed by the work platforms of the service structure, ready to undergo vertical checkout and flight preparations. Later, the service structure was rolled away, and the Saturn stood alone on the launching pad for the first time, while various radio frequency tests were conducted. Long before the Saturn was erected, though, back at the Marshall Center's Computation Division, the vehicle was being mathematically flown thousands of times inside this powerful IBM 7090 digital computer. Such simulated flights saved NASA months of man effort and many thousands of dollars. Using analog computers, Computation Division had also solved numerous Saturn problems. For example, equations which describe the draining of the liquid oxygen tanks when the booster is fired. Parameters of the system, such as orifice sizes and tank diameters, may be varied by adjustment of potentiometer dials. Variables of the system, such as liquid levels or draining rates, are automatically graphed on the XY plotter in order to provide engineers with necessary design information. Continuing Saturn wind tunnel tests, such as this one using the Schlerin optical technique, were run this quarter by Marshall's Aeroballistics Division. The test produces a picture of the airflow present around a Saturn model, thereby revealing any undesirable aerodynamic effects caused by body shapes or test conditions. A 1/20th scale Saturn booster model was also tested in a 16-foot diameter wind tunnel at Tullahoma, Tennessee, to measure the heat around the booster's base while undergoing various flight conditions. Using these small tanks, a series of demolition tests, photographed at high speed, were run by Structures and Mechanics Division to determine the most effective means of range safety destruction of a Saturn vehicle in the event it should veer dangerously off course. Employing 100-grain, primacord, and flexible-shaped charges as the explosive devices, tests indicated that the latter will initiate an explosion of less violent intensity, resulting in a minimum amount of blast destruction, thus realizing a higher degree of safety for both personnel and equipment without sacrifice of reliability. Dynamic vibration testing of the test booster, called SAD in the new dynamic test stand, was delayed from June 23rd to July 3rd. In order to allow time for installation of wind screens around the stand. The screens enable testing to be carried out in winds up to 15 miles per hour. The SAD vehicle, a simulation of the SA-1 configuration, was suspended on steel cables and excited through a frequency range sufficient to determine the significant bending, torsional, and longitudinal mode shapes and frequencies, including the damping coefficients associated with each mode. Flight time conditions tested included liftoff, 35 seconds, 63 seconds at which maximum aerodynamic pressure is reached, and 119 seconds or cutoff. Tests were conducted by S&M Division, together with Guidance and Control Division. The huge SAD booster is suspended in the dynamic test stand in a manner similar to this tiny functional model, which is used by GNC Division to conduct preliminary investigations. Such information as effect of suspension on bending modes, spring resonance effects, and pendulum motions can be studied here, since the model can be pre-calculated. Research on a new method of measuring torques in air bearings, used in Saturn's guidance and control system, was also conducted by GNC. The flow of air within an air-bearing gyroscope exerts a small, undesirable force which tends to rotate the floating member of the bearing. Since the gyro cannot differentiate between this force and an actual change in vehicle attitude, it became necessary to devise this apparatus to accurately measure the force in units of dyne centimeters of torque for analysis and elimination of its causes. Static testing continued this quarter with 5 firings of the SA-T2 booster, which simulates the second flight booster SA-2. The final SA-T2 firing on August 25th was a successful engine-out capability test, in which one engine was intentionally cut off at 94 seconds, while the others ran to 114 seconds duration. Assembly of the SA-2 booster, begun on December 27th of last year, was completed on August 1st. And checkout of the vehicle by Quality Division started the same day. Assembly of the third Saturn flight booster, SA-3, got underway July 31st, and the last tank was installed near the close of this report period. Fabrication was initiated on the fourth flight booster, SA-4, on July 31st. The relatively new process of micro-welding, in which the operator must use a magnifying glass or microscope, illustrates the wide range of activity, from the mammoth to the minute, being accomplished in Marshall's FA&E division. Wires or sheets as small as 1/1000th of an inch in diameter or thickness may be joined by this process. While booster and dummy S4 fabrication continued at Marshall, manufacture of the Flight S4 stage was underway by the contractor, Douglas Aircraft Company in California. The new technique of explosive forming, shown being tested in this slow-motion sequence, is expected to accelerate S4 tank segment fabrication. Besides vehicle manufacturing, work also moved ahead on ground support equipment, with several GSE test sets and control panels virtually completed. Construction of Douglas 90,000-gallon liquid hydrogen storage tank and liquid oxygen storage tanks has recently been concluded. A concentrated buildup of facilities at the Marshall Space Flight Center was also in progress this quarter, including excavation work on the new $10.8 million static test facility. Additions to the Fabrication and Assembly Engineering Division. A 5-story addition to Structures and Mechanics Division. And a large new pressure test cell for Quality Division. And at Cape Canaveral, site clearing and earthfill was being done for construction of a new Saturn complex, Vertical Launch Facility 37, designed to handle launching of Saturn vehicles through the more advanced stages. Meanwhile, approximately 5,000 feet to the south at Cape Canaveral, the first Saturn flight vehicle stood poised on its launching pad at Complex 34, and preparations were well underway for its scheduled date with history.